All right. Sorry, guys, for the little delay. All right. So last class, you guys took your CIA. Class before that, you took your test on Unit 1 for quarter 3. So let's take a look at your next unit. Okay, and if you thought last unit was hard, I think this unit is a lot easier and it's a little bit shorter. So we'll be finished with this topic right before Thanksgiving break. And then you're already almost done with quarter 2. Kind of crazy. Okay. So this next unit is going to be on exponentials. Okay, exponentials and logs. Today we're only going to cover exponentials. And you did a little bit of this in algebra 2, but I know it's been a minute. So first thing I want you to do is graph the parent function. Okay, the parent exponential function is y equals 2 to the x. Okay, now if I was going to be really extra, I would make you type it into the calculator and look at the picture. Okay, but I'm not going to. I'm just going to give you the points. Your graph should hit here at 1. Then it should hit at 2. And you're going to keep doubling. So 2 would double 2. 4. 4 would double 2. 8. And so essentially what happens is that this side of the graph is going to get really, really big, really, really fast. Now, the other side of the graph, you're going to cut in half each time. So this is going to be a half, then an eighth, then a 16th. Okay, then an even smaller, tinier fraction each time. So on this side, you're going to get really, really close to the x-axis. Closer and closer and closer. Now, you're never technically going to get there. That's called a horizontal asymptote. So right here, I want you to draw, okay, that your graph has a flat or horizontal asymptote at 0. Okay, but it's only approaching it on the left side. And then the right side is going to grow exponentially. So this is called exponential growth, which you should have seen in algebra 2. Now, the good news about these equations is that just like all the other ones, they follow all the same rules. So will you take a look at number 1? Do you see that they have a -3 in the exponent with the x? Take a guess, which way is that going to shift my graph? Forward or backwards? Think about all the rules that it usually is. Forward, very good. Because remember, that one's always the opposite. You never trust your x, right? So if it's a -3, I'm going to go to the right 3. And then the +5, which way are we going to go? Up 5, good. So go to the right 3, up 5. And then I want you to draw in your horizontal asymptote. Okay, which would be right here. Then remember, that's the line that my graph can't touch. You're going to start your graph exactly 1 box above that center. So I'm going to start it here. And then remember, my y values would double. So I'd go 1 box. My next would be 2 boxes. My next would be 4 boxes. And it would grow really, really fast and then shrink down to the asymptote. Okay? Yes. I went to the right 3 and then up 5. That's where I drew my flat line. And then my first actual dot is 1 dot above that. Okay, you're welcome. All right, your horizontal asymptote was at y equals 5. Okay, because that's where my flat line is. And then for the domain, do you see that both ends of this graph are going like arrows? So what would my domain be? Infinity, or let's put all real numbers. You remember that symbol? Now, for your range, remember range instead of side to side is up and down. So I am going to go up forever, but I can only go down until I hit that yellow line and then I can't go below it. So what's the lowest that this graph can go to? 5. Very good. So your lowest value is 5. your highest value would be infinity. Now, normally for 5, we would give it a bracket. I don't know if you remember that. Okay, but a bracket means that you get to 5. And can I get to 5 if it's a horizontal asymptote? No. So just like I can't get to infinity, I'm going to parentheses on both sides. And remember, all the parentheses means is I'm going to get closer and closer and closer to 5, but I never actually get to like touch it, if that makes sense. Okay. Let's do one more like that. Take a look at number 2. I have an x minus 4. Which way are we shifting? To the right 4. And then my minus 6 means I'm going to go down. So right 4, down 6 would be here. Okay, and then remember, you're going to take that dot, and that's where your flat line goes. So I'm going to draw it in through this spot right here. Your horizontal asymptote then is y equals -6. And remember, that's the line that your graph can't cross. It's going to get closer and closer and closer, but it's never going to get there. Okay, normally your first dot goes exactly 1 box above that. Yes? Yes? Okay, but I have a 3 in front. Do you remember what that does to how many boxes away I start? Do you stretch or compress? Stretch. So I want you to write right here that that's a vertical stretch. Very good. And that's going to stretch how far away your first box should go. So instead of my first box just being up 1, it's going to be up 3. Okay? And then for your homework, you don't have to mark every dot. So we're just going to draw the graph, but it would go like that. So you don't have to mark every single one perfectly. Just get the idea that to the left, it's flattening out. To the right, it's growing exponentially. Okay, then your domain would be all real numbers. And your range would be from -6 to infinity. Okay, remember, both parentheses on that, because I'm not going to actually get to touch -6 because it's an asymptote. Okay, last one like that. I have a +5 and a -1. Which way are we going to shift for the +5? Left and then? Down. Very good. Left 5, down 1. Draw in your horizontal asymptote. Normally, my first marker dot is 1 box above. Okay, but how many boxes will I go this time? Make sure you look at that front number. A half a box. And what will the negative do? It's going to compress. Instead of going up a half, I'll go down a half. Okay, so it is still a vertical compression because I'm shrinking how far away that first box is. Okay, but it's also going to flip it. And then I'm going to put ROXA because I think a lot of the Algebra 2 teachers say that. Remember, that means reflect over x-axis. So it's going to flip it down. So let's draw it. Go half a box down. Doesn't have to be perfect. And then normally, don't draw this. I mean, I guess you can if you want to. But normally my graph would go like this, right? So then I would want to take that graph and flip it. So now it would look like this. I'm going to go flat on this side. And then you're growing away from the x-axis down, if that makes sense. So this is like where your original would have been. And then this is where it would flip to once it's upside down. Horizontal asymptote was at -1. What will my domain be? All real numbers. Because I still have an arrow going that way and an arrow going that way. Okay, but now your lowest and highest are going to be kind of weird. Because my graph doesn't go up forever anymore. Which way does it go forever? Down. Down. So my lowest would be -infinity. And my -1 is the highest that it can go. Because now that it's flipped, it can't go past -1. That's the tallest it can go. Does that make sense? Great. All right, so the first part of your homework you should be able to do, but we're gonna just go ahead and finish the notes since it's like not much so far. So turn the page. You are gonna notice on the next page that you have a list of common powers. Okay, I would not expect you off the top of your head to know what 5 to the 4th power is. Okay, so some of the squareds you probably know, like 2 squared is 4, 3 squared is 9. Okay, so most of that top row you probably have. Okay, but these other ones are here so you don't have to look them up in the calculator. Okay, so we are going to solve today by what's called common base method. So you are going to rewrite each side in terms of a common base. That's where your chart comes in. Then once you have a common base on both sides, you can cancel them out and set the exponents equal to each other. Then you're going to solve. So let me show you what I mean by that. Take a look at number 1. On the left side, I have a base 2. Now base is referring to like the big number at the bottom. So I want to turn my 64 into a base 2 as well. So I'm going to look in my 2's chart. Do you see 64? 64 is the equivalent of what? 2 to the 6. So then I'm going to switch this to a 2 to the 6. So now here's what my equation says. 2 to the 2x equals 2 to the 6. But remember, that's where you're using the chart to find the equivalent common base. Then from there, the next step says I can do what with those common bases? Cancel them out. So if I have a base 2 on both sides, whoop, whoop, cross those out. Then I just have 2x equals 6, and then I can solve it regular. So what would I do to get rid of a multiply 2? Divide. Very good. So divide by 2 on both sides, your x is 3. Okay. Let's take a look at another one here. Let's do number 3. Okay, if you have a big number and a small number, you want to turn the big number into the small number. So my smaller base here is a 5. So can you look up 25 in the 5's chart? Do you see it? It's 5 squared. Very good. So let me show you what I mean by that. Here's 25. It's the equivalent of 5 squared. So what we're going to do is we're going to come down here to where my 25 is. I'm going to turn it into a 5 squared. Now, if there's already an exponent, you can't just get rid of it, but you're going to group it together behind that I already had an x minus 3 on that side. So the 25 is turning into the 5 squared, and then the old exponent that was already there just needs to be grouped. Now that I have a common base of 5, what can I do with it? Cross them out. Okay, then up there in the exponent, my 2 is outside of the parentheses. What do you think we're going to do with that? Multiply it in. So I'll do 2 times x would be a 2x. Minus 6, very good, equals 10. Then from there, you're just solving. So to get rid of a minus 6, I'm going to plus it across. So that gives me 2x equals 10 plus 6 is 16. Then last step, divide by 2. So x equals 8. All right, let's do one more like that. Take a look at number, let's do 6. Okay, which of my bases is smaller, 125 or 5? 5. Then I want to turn 125 into a base 5. So remember, big can be changed to match small, not the other way around. So in your 5's chart, what is 125 the same as? 5, 3. Very good. And what do I do with the old exponent? Group it in parentheses. Now, on the 5 side, if it's just a regular 5, that's considered 5 to the 1. So if there's not a power there, you would say that's 1 5, right? Versus 25 would be 5 times 5, you'd have 2 of them. So then cross your 5s out, solve. So my 5s are gone. My 3 is outside parentheses. That means we need to multiply. So I'll have 3 times x is 3x. 3 times minus 2 is 6, equal to 1. Next step, what would I do? Add the 6 across. Very good. 1 plus 6 gives me 7. And then last step, do what? Divide by 3. Very good. Now, if your homework gives you a question that won't divide, you'll just leave it as a fraction. So your answer here would be 7/3. Okay, and you will get some on your homework that are fractions. That's fine. Okay. All right, let's do one where we have an x now on both sides. So can you look at number 4 for me, please? I have a 2, 16, and a 6. You're going to look up the bigger number in the smaller numbers chart. So find your 6's chart. Do you see 216 as a base 6? What is it? 6 to the what? 6 to the 3. And then I already had a what on that side? An x. So I'm just going to group it in parentheses. On the other side, I have a 6 to the x minus 4. Now notice I don't have to change the 6 side because that was already the smaller base, right? So then from there, what can I do with the 6's? Cross out. Remember that if you have an OG base that was already there, you're multiplying it with the new number. So 3 times x, that would go to a 3x. Okay, and then from here, how do I solve that?
At x.
We do want to get the x across, not by addition though.
Oh,
Subtraction. Good. So we'll just minus that x across. So x minus x will cross out. What is 3x take away an x?
2x.
So 2x is negative 4. And then last step, divide by 2 on both sides. Very good. Questions on this? All right, go ahead and turn the page. So you're going to still maybe need that chart, but we're going to go on to the next set of examples. If you have a 1, you should know that any base that you want to the power of 0 is 1. So 10 to the 0, that's a 1. 5 to the 0, that's a 1. 6 to the 0, that's a 1. So if you get an equation where you're trying to get it to equal 1, you can use whatever base you want as long as you put a 0 on top. So my 9 to the x minus 6 is going to stay the same. And my 1 is 9 to the 0. Because remember, any power 0 gives you 1 as the final answer. So I'm going to pick the base that matches the base I already have. Then now that those 9s match each other, I can do what? Cross them out and solve. So my 9s are gone. X minus 6 is 0. And then what do we do to solve?
Yes.
Good. So 0 plus 6 means x equal to 6. Okay, but you would only use an exponent of 0 if you're trying to get a 1 to match a base on the other side. All right, take a look at number 8. You'll notice that the rest of the questions here have fractions. Ethan, will you grab the notes, honey, please? If you have a number on the bottom, the way that you can pull that number up, you should have learned this in Algebra 2, is that you can just turn the exponent negative. So if my base is to the m power, but it's on the bottom, for me to pull it up, I just make it a negative m. So let me show you what I mean. Take a look at number 8. Can you please find 64 in the 2's chart?
4 to the 3rd.
We have to use a base 2 though. 4 to the 3rd won't work because then I can't cross them out. 2 to the 6. Good. Okay, now I can't cross out the 2's because this 2 is on the top, but this 2 is on the bottom. What I can do though is bring this 2 up by turning the 6 to a negative 6. So I'm going to use a negative exponent because it was a fraction. So now I have 2 to the x, 2 to the minus 6. And then from there, everything's the same. What would my next step be? Cross out the 2's, and then normally I'd have to do a little bit more work to solve, but in this case, I have my answer. This is an x equal to a negative 6. Okay, so fractions, you're going to use a negative exponent, but other than that, the solving's the same. Okay, let's go down to number 10. Okay, I have a 64, and I think, Jacob, you just looked this one up in the 4's chart.
Yeah.
What was 64 as a base 4?
Oh.
Didn't you say it was 4 to the 3? Yeah. So then this would be 1 over 4 to the 3. But then I would say, wait, I can't cross out 1 4 on top and 1 4 on bottom. They have to both be on top. So for me to fix that, I'm going to pull my 4 3 up, but turn the 3 to a minus 3. So you have 4x minus 1 squared, 4 minus 3. Questions on that so far? Or are we good? Okay, cross out your 4's. And then remember, any original exponents you're distributing. So when I get to this left side where the 2 is outside of the x minus 1, I will still have to times that in. So 2 times x would be 2x. 2 times minus 1 would be a minus 2. And then on the other side, now that the 4 is gone, it's just a minus 3 left. From there, how would I solve? Good? Uh-huh. So I have 2x on the left-hand side equal to a negative 1 on the right-hand side. And then divide by 2. Uh-huh, that's right. And then remember, if you get fractions on your homework, that's fine. No big deal there. Okay, last one we'll do off this page. Let's do 11. Okay, this time my fraction has something on the outside. You're going to work it the exact same way. What number am I looking up in what chart?
9.
I'm looking up 9 in whose chart? The 3's chart. Very good. 3 squared. Very good. But if it's a 3 squared on the bottom, I'm going to turn that into a what? 3 negative squared. Very good. And then remember, the old exponent has to stay there, but you just put it in parentheses. So my 9 would go to a 3 squared. I'd apply the negative and keep the x behind it. On the other side, I have a 3 to the negative 8. And then we're going to cross out those 3's and keep solving. So now we have a negative 2x equals a negative 8. What would my next step be? Uh-huh. And remember, if you have a negative number in front of your x, you're going to divide the negative with it. So I'm dividing this by negative 2 on both sides to cross that out. And then remember, a negative divided by another negative is going to come out how? Positive. Okay, so just because your question has a fraction in it, your final answer may come out positive. That's possible. Okay? All right, turn to the last page. We are almost done. Okay, the last thing is what I am going to call non-compatible bases. Okay, and the reason that I say that is, will you take a look at number 13? My bases are a 9 and a 27. Normally, here's what I would have you do. Look up 27 in the 9's chart. So can you go look at your 9's chart? Is 27 ever in there? No, that's why I'm saying they're not compatible. Then what you're going to do is find a smaller base that they're both in the chart for. So I'm looking for 9 and 27, but in the same chart. Very good. In the threes chart. So 9 is going to go to a what? And 27 is going to go to a 3 cubed. Very good. So you're just looking for, if you can't find big and little, then you're going to have to find both of them in a littler base. Okay. So my 9 is a 3 squared, original exponent in parentheses. My 27 is a 3 cubed, original exponent in parentheses. And then we're ready to solve. My 3's are going to cross out, just like usual. So those are gone. And then remember, if you have an exponent with an old exponent, you're multiplying. So what will that left side come out to be?
Oh, wait, that's.
Yeah, this
2x
side.
plus 6.
So 2x plus 6. Good job. We're multiplying it into both terms. And then on the other side, that's a 3 times 2. What's that? 6. Okay, then we want to keep solving. So how do I get rid of a plus 6? And minus 6. So I have 2x equals, what is 6 minus 6? 0. 0 counts as a number. Okay, so we're going to keep solving. How do I get rid of the 2? Divide by 2. What is 0 divided by anything? 0 is your answer. And I'm pretty sure there is one question where 0 comes out to be your answer. But remember, it's a number just like anybody else. Let's just do one more. Let's do 15 with an X on both sides. So normally I would find 32 in the 4's chart. Okay, but since we know we're in the non-compatible basis section, we know 32 is not going to be in the 4's chart. Where are they in the same chart? The 2's. 4 is going to go to a what? 2 squared. Old exponent in parentheses. 32 is going to turn into a 5th. Old exponent in parentheses. And then once you have those common 2's, you can slash them out and then keep solving. Remember, exponent and exponent, you're multiplying. So 2 times x is a 2x. What will I get on the other side? Perfect. Now, in this case, you're trying to get your x's alone. Do I bring the 2x over to the 5x or push the 5x over to the 2x? I would move the 5x because you're trying to get them away from the 40, right? So I'm going to minus my 5x across. That gives me just a negative 40 on this side. Negative 3x on the left because 2x take away 5x. And then remember, if your x has a negative number on it, you divide that whole negative number across. So I divide the negative 3. Will 40 divide by 3?
No.
Yep, then you just leave it as a fraction. Okay, if you try to type it in as a decimal, delta math will kind of wrong. So just leave it like that. Good? Okay. Bottom 2. Let's do the first one. Can you look up 25 in the 5's chart for me? These are compatible, so you don't have to find a smaller chart. What is 25 as a base 5? Good. Okay, so we have this. And then we're turning the 25 into a 5 squared. Old exponent stays in parentheses. So far, nothing weird has happened. What is the next step? Cancel the 5's. And then we're going to bring our exponents down and set them equal to each other. So far, this is the same. I have a 3x squared plus 12 equal to, and then I'm going to times this 2 in. So 2 times minus 9 would be a minus, and then 2 times minus 6 would be a minus 12. Okay, then you get to this point that we're trying to solve for x. If you have an x squared in your answer, you have to solve by factoring. Okay, and so let me remind you how to do that. All your crap has to be on the same side. So I'm going to bring my 18x over. That's going to give me 3x squared plus 18x plus 12 equal to a negative 12. And then remember what I said, we're bringing everybody over. So I brought the minus 18x over. Now it's a positive 18x. How will I move the minus 12 over? Add 12. Now, when I add it, if there's another number by itself, I have to add it to that number. So I'm going to add this 12 to that 12. So that now all of my terms are on the same side. I have a 3x squared plus an 18x plus a 24 equal to 0. Okay, you should know how to solve that. Okay, you're going to have to solve it by AC chart. If it's got an x squared and an x and a number, that's an ABC. Now, is there a GCF that we could take out that would make our numbers smaller? Yes. So if everything can do it, let's divide that 3 out. So now this is a 1x squared. 18 divided by 3 is a 6x. 24 divided by 3 is an 8. Okay, but you only have to resort to AC charting if you have an x squared and an x. Okay, then from there, I'm looking for numbers that will multiply to 8 and add to 6. 2 and 4, very good. Those are my guys. Now, there are other numbers that times to 8, but 2 and 4 are the ones that times to 8 and add to 6. So I have my A as a 1, so I don't have to divide and slide. So I have an x plus 2 and an x plus 4. Then what are my final answers if I have to switch the signs from the parentheses? Do you remember? So if it's a plus 2, what would my final answer be? Minus 2. And then if I have a plus 4, it would be negative. Okay? But unless there's a squared in it, you should only be getting one final answer. If it does have a squared in it at the end, you should have 2 answers. Okay? All right, we're going to do one more like that, then we're done with notes. Okay, the next question, your bases are 3 and 27. Can you look up 27 in the 3's chart? 3 to the 3, very good. Now, if they're fractions, what do I have to do to the exponent on the 27? Good, so this is going to be a 3 to the minus 3. And then on the other side, I already have the 3 that I want, but what exponent goes on the 3 if it's just a regular 3? What number? 1. And if I want to pull it up, I have to turn it to a negative 1. Very good. So this is a 3 to the negative 1. And then I'll keep this crap up here. Like that. So this is a 3 to the 1 coming up. And a 3 to the 3 coming up. And when they come up, you just apply a negative. Okay, from there, the 3's are still going to cross out. My negative 1 is going to multiply into my parentheses. So now that's a minus 2x squared. What will the sign be on the 10x? Positive 10x. Okay, on the other side, we're bringing a negative 3 onto a negative 2x, positive 6x. And then, ooh, we may need calculator for this one. Negative 3 times 42. What's that? 126. Thank you. Now remember, if there's an x squared, you got to get everybody onto the same side. So when I move my 6x over, where will I have to line it up under? The 10x. If there's already a like term, you want to stack those. So when my 6x comes over as a minus 6x, I'm going to take it away from the 10x. How many will I have left? 4x. Very good. Then my minus 126 is also going to have to join everybody else, but when it goes to the other side, what sign will it have?
Plus.
Plus, because if it was a minus over here, we're going to plus it to get it on that side. So here's what you have. Now, like I said, if I got an x squared, I know I'm going to have to AC chart it. Is there a GCF that will make my AC chart easier? 2. Now, if the front one's negative, remember you should divide by -2. So I'm going to put here GCF divide by -2. So my minus 2x squared is now a 1x squared. What is my 4x when I divide by a -2? And then my 126 divided by -2? 62. Oh, thank you. 63. And then we're going to AC chart. Can anyone think of numbers that will times to 63, but subtract to a difference of 2? 9 and 7, very good. 7 times 9 is 63. But now I have to pick which side I put the minus on because this is a subtraction chart, right? If I want the 2 to come out negative, do I want it to be on the 7 or the 9? 9. So my factors would be an x plus 7 and an x minus 9. And then remember that your final answers are the reverses of those parentheses. So if I picked a plus 7 in my AC chart, my answer is going to be a minus 7. And then if I had a minus 9 in my AC chart, it'll be a plus 9 for my answer. Make sense? All right. I'll bring you scratch paper and go ahead and get started on your adults math. Okay? Okay. Do you want the notes now? Wait. Both?
No, next Wednesday. I don't know what you're gonna say after that.
Okay. I can give you, I already have the homework
Okay,
typed
can I
out
get
if you
the-
want it. Yeah.
Hey.
Hey.
So I got a document.
That's okay.
I forgot about.